Morning, everyone. This is Steven from IPF Force, and we are working on the Velas and the Filecoin, one of the Filecoin clients implementations. So today I want to share the Velas design and architecture and development. Velas is a modularized design, and it is for Filecoin storage providers, the software. So firstly, we actually start designing Velas when the Filecoin mainnet is launched in 2020. I think it's September. At that time, whole community already have Lotus, right? Why we need to have Velas? And we are thinking about this. So Lotus by itself is actually for the whole community, and it could cover many requirements. And for Velas, actually do some analysis of the mining pool and the miners from BTC. If you say the BTC turn of miners, you will say that in the initial stage there will be many individual miners, but while the market is mature and miners will be consolidated. Okay, there will be more professional miners, right? So that is the trend. So for Velas, we want to build a software collective for enterprise miners and for the professional miners. So we think that perhaps for Filecoin, a few years later, there will be more and more professional miners. We were right. Actually, right now there are many SPs are very big. They are very professional. Okay, so now it's come to the Velas product suite. We have the modularized design, and there are 3 layers here. The first layer, we call it Sofen. It's chain service. And the second layer is about, so the chain service itself is for the chain, for chain synchronization, for the block generation, and the message handling, and all of this, right? And about the network, the consensus. And the second layer is about dynamicless. This one is especially for the ZK, for the storage proving. Okay? And is droplet. Droplet is for the storage deal, storage deal service. Let me say it one by one. Okay. So firstly, is Sofen. So here if you say, actually we have many components. We just group them into 3 parts. And we name it by using the name from 3 body. Perhaps all of you know that is sci-fi fiction, right? Sofen, firstly, is about chain service. If we want to know Sofen, here is the whole picture of this. So as a professional SP, they may have a lot of hardware, okay? Their hardware, their service might be distributed in different data centers. So here we show that, there are multiple data centers. You could only run one Sofen component as a chain service, and then you could have multiple miners to connect, to use the chain service. So actually, the Sofen chain service can serve more than 100 SPs. Each location, you have a droplet and domain class deployed, and to share the Sofen. So in this way, here we'll show this, okay? And we also have a component in Sofen. There are so many components here, including the Sofen core and the Sofen OS, Sofen miner, messenger, and gateway. All of this put together as a chain service. First, we'll talk about the Sofen core. Sofen core is actually a high available solution for the chain service, so that you could run Velas, one component, and you could run another Velas instance. Okay, you could run multiple Velas instance, or you can run a Lotus instance together, and use Sofen core to provide this service for all the SPs. And the Sofen core can select the best one to serve. It's because any one of instance, they may have fault. Okay, they may have a hardware problem, and they may have some network issue, right? So the chain synchronization might be behind. So the Sofen core could choose the best one to serve. So as you can see here, If you have multiple miners, you have multiple miner IDs, you only need to run perhaps 2 VLAS nodes, okay? And you have the Solfan core, and then actually you save the cost, right? Yeah, because you don't need to run so many chance service, and at the same time you get the high availability, right? Yeah, for example, you have 100 each instance of chance service for each one, but anyway, you don't have the availability, right? So now you have a low cost, high availability here. Yeah, that is very good, right? So here also I want to mention that actually we could have VLAS node, Lotus node work together, okay? Here. And also here I want to mention another component is VLAS wallet. Yeah, you can also call it Solfan wallet. So there is one pain point for SPs is because the SPs need to hand over the private keys to engineer to maintain the network, right? To maintain the load. So we have the wallet, VLAS wallet, separated. Actually have some advanced features. For example, we have the access control. So you could say that this wallet, this individual private key can only send what kind of messages. So for example, you could have a rule there to let this address can only send, for example, the pre-commit, and you cannot transfer the token to another. We have the access control on the wallet. Okay, this is one thing, okay? Have this wallet to save all the private key for many miners, many miner IDs. So you can have one engineer or one privilege, perhaps a manager at this machine, okay? So and this can be used with Lotus too, okay? So with these two components, the Solfan core and VLAS wallet, I think many SPs are already using this. Not only the VLAS user, actually many SPs, they're using Lotus. They're using this. I guess for this one, perhaps about 30% of the whole network are using Solfan core, and for the wallet, perhaps more than half SPs are using this. Okay, and also some other component. For example, the messenger is to handle the messaging, especially to prioritize your own message. You can also to make some rules for this message. So there are still some advanced features you can use. Okay. The second big component is Democrats. Democrats is for the storage power service. Simply speaking, is about the selling. Okay, is about the proving. Proving is very actually computing consuming. So this is very important to how to optimize it. So here we have this different, I think, the message. Different methodology of comparing to Lotus is because we have different scaling mechanism. Lotus is actually active scaling, which means the scheduler will ask the worker to do something. And for VLAS is actually workers, while a worker is idle, complete one work. So the worker will automatically to ask tasks from the scanner, from the scheduler here. So that's a different. Okay, this difference is huge, is because we could keep all the workers always busy. Is because once the worker is idle, do not need to manage the status of the worker. Okay, we just monitor it on site, and the worker could be kept always busy. So the usage of the computing is very high. This is one thing. And another thing is that actually the workers in this scheduling mechanism, we could actually linearly increase the computing to the network. So you could as many as you can of the workers into the system, and the performance will be linearly increased. Okay, this is very important feature. Is because the worker is asking the task. So the scheduler could work for many miners. So for example, we have 10 miners, okay? So This is actually a computing pool, okay? The computing pool, if you miner to register in the scheduler, and the scheduler have all the tasks, the scheduler could assign. Once the worker is asking a new task, and scheduler could tell the worker, you do this task for that miner. So this pool could actually work for many miners. Okay, one more important feature here for our seeding process, proving, is that we use plug and play mechanism here. So we know that the seeding, the whole process, there are many steps. For example, the adding piece and to do 3D, and we have the PC1, PC2, C1, C2, right? You need to move the data from one storage to another storage. So here we could have everyone to be plug and play. That means, for example, many SPs, they have their own customized seeding algorithm. They believe an algorithm is very good. Already in the system, have run that for a long time. They don't want to change it. So here we have the mechanism. You can use your own algorithm and you compile it into individual binary, okay? And you just plug in. So how you can plug in? It's like this. It's very simple, okay? You just to modify the configuration file, okay? For example, your binary here, and as a pass, into this, for example, the processor, this one, your executors, okay? And also to add some arguments here. And okay, the VNAS, demo class components will automatically use implementation here, okay? So it's very easy to change and to plug in. And also here, in the last few months, we have done a lot of things to optimize the proving algorithms. So here, I believe that this is fastest, okay? In this whole community one. The most efficient one. Here, if you say that, okay, the new one comparing to the old one of the VNAS, the demo class, we improved a lot. For example, the PC2 time, before we need about 10 minutes, now we only need 2 minutes to complete the PC2. And also for the C2, we improved a lot, and actually 80 times performance, okay? Before it's 16 minutes, and now only need 2 minutes to complete C2. And also for the stop deal, for 1 day, we can only have 4 TB onboarding. So now we could have 22. You could say it's a huge improvement, right? Very huge. More than 5 times, for each of them. Okay, the last one is Droplet. The Droplet is deal service, okay, is for the data onboarding. So the difference between, and again, the difference between the VNAS market, Droplet, Boost, okay, is that we have another feature is the Droplet could support multiple SP. Just like I mentioned, and other 2 components, right? They could, all of this could support multiple SPs. And here you could have the Droplet installed, and you could have multiple miner IDs connect to the Droplet. And one instance could save multiple miners. And we have a separate peer store. Okay, here is actually the VNAS max total power. I think I take this at the beginning of this month. Now we have all of the network QAPs is over 10% of the whole network. This looks not that big, but it's very difficult for us too, is because Lotus has dominated this market, right? And at the beginning, and we just onboard VNAS, I think, 2 years ago. That we don't do much about the marketing, and we just have some friends. And all of this is free. Because the SPs need to change their Lotus configuration to VNAS. So, and the cost is also high, right? 10%, I think, is still a very, very important milestone. A good thing is that we see 200% year-on-year increase, okay? And in last 2 months, actually, we have 300 petabytes power growth, which is also good. We count this is only from Droplet, from marketing side. But actually, as I mentioned, there's some other components which can use for Lotus and also can use for Venus. The market share is much higher than this. Okay, for example, as I mentioned, the Solfan, Core, and the wallet. So the market share is much higher. Okay, thank you. And if you want to join Venus development or community, and you want to ask any questions, you could follow this. And you could join us in Slack or WeChat, and you can send an email to us, okay? And this one, I think, is the Telegram. Send us a message, okay? If you want any help or any technical support, it's totally free, okay? Thank you.
Thank you so much. Are there any question for Stephen? Yeah, Shranuj has one.
Hey, Stephen. Thank you for the presentation. So one of the things you mentioned was that you have components pretty modular components, one of them being the Solfan wallet, which you can integrate with Lotus today as it is. What other components can you try to integrate with Lotus today with very little obstacles? And are there some things that we can do in Lotus to make that easier as well?
I think the first thing is that we need to, so the whole thing is that I want to, this is also I want to discuss with those team is that we should, Filecoin is very complicated, right? The whole protocol stack is, and all these things, we should have some standard to do this. So anything could be modularized. We could to have some individual module to replace. So here, I just mentioned two here. Is a Solfan wallet. Because Lotus wallet can be, can also be separated, right? And in an individual computer, so we can replace that. Because we have the same interface and we have some other APIs, but it's a plus. Okay, so if we have this kind of competence, it's okay. And also the Solfan Core is because it's another layer, so it's also and another layer which can provide the same API as Lotus and Venus, so it can work together. And some others, I would think that if we use, for example, I think this one is very, perhaps we want to follow here is because we have, you would define this kind of interface, we have the standard, and everyone can design or implement their module, right? If they follow this kind of interface.
So essentially we need to define some sort of, we need to work to define a sort of standards for the interfaces which we want to build out.
Right. That is, please.
You mentioned that the cost of switching from Lotus to Venus was high, and then the software is free. What makes the cost high?
Yes, because the design is a little different, right? And the first thing is that the Filecoin implementation is really complicated, and because the Filecoin itself is complicated. There are the blockchain, the network, and the proof, and also the data onboarding, the deal handling, many things. So what I know is, especially in China, there are many SPs. They already customized their code, okay? While they customize their code, their engineer, especially an operation and maintenance engineer, are really familiar with their customized code and the network. But they call them Lotus. It is kind of different from the native Lotus, but anyway, they call them Lotus. So if we want them to change to Venus, they will learn some new things. So that is the cost.